paper is being presented remotely by, I believe it's Christoph. I can't pronounce his last name. What is it?
Christoph Thiede.
Very good. A directional microphone. Okay, we all set? Let's go.
Okay. Yeah. Thank you for the kind introduction, and welcome to my presentation. Hope you have a nice weather in LA. And in the beginning, I'm talking a bit about what is exploratory programming at all, because if we want to talk to objects in natural language, then we need first to define what this is. So we are talking about programmers who want to work with exploratory programming systems, and we want to use objects in different systems, and we want to ask questions about them. So our goal is to develop systems iteratively and to understand how systems work. And for this, programmers might have different questions, such as what is this object about? How can I invoke this feature? Or why does something not work as expected? And to achieve this, the programmers can interact with the objects in the different system. And for this, they need to perform a lot of technical experiments. And this can become pretty complicated because all these experiments require technical tools and writing code and weapons and things like that. So
Christoph,
this can lead to a lot of complexity. And
the slides are still on the title slide.
Oh no, this is very wrong. Okay. It says it shares my entire screen. I will reshare it. Can you see it now?
Yes, we're on motivation. Page 9.
And
10?
now another title?
Yeah. Page 10.
Okay, so I hope that it's updating now. Okay, so where had I stopped? So I was talking about the complexities of experiments in when interacting with objects, because we have technical interfaces and we have a lot of complexity in communicating with the objects in the system. And also the results can be complicated to understand, and all of this creates a lot of complex experiments and technical overhead in the process, and also cognitive overhead in programmers. And on the other hand, we already see in different areas of software development today that there are already generative AI agents that support programmers at different tasks that are related to comprehending or interacting with source code. So we wondered, why can we not also use such agents to support, to streamline and augment the exploration of objects? And this leads to our proposal. Here's a sneak peek of it. We propose an exploratory programming agent.
Christoph, your slides are still not advancing.
Okay, I will try something else. Sorry for that. I hope it works better now.
Okay.
Can we now? Yes?
Yes.
Okay, then I hope that it works this time, and I apologize. Okay, so we propose that we have just an exploratory programming agent which sits between the programmer and the system and allows programmers to ask their questions as natural language questions, and then the agent can perform all the required experiments on their own, and finally provide the programmer with another high-level natural language answer. And formally, this leads to our research question. Can you still see the new slides now? Slide 13?
No, we're still on 11.
I have no idea why this is happening.
Now it's 13.
Okay, so, well, maybe we just have some delay. Okay, I just will hope that it works. So our research question is, how can we support exploratory programming through semantic object interfaces that enable contextual natural language conversations with robot objects? And for this, we make three contributions. First, we propose a framework for semantic object interfaces. Then we present our prototype for using this framework in a Squeak Smalltalk context. And finally, we evaluate our idea based on our experiences. Let me now give you some extended background. I hope to now on slide 15 as well. Can you see slide 15?
Can you maybe not use full screen?
Yes,
For the
slide
slide.
16.
For the
So
slides.
I hope it's still up to date. Okay. And so it gives you a more precise definition of exploratory programming. We define this as a setting where programmers understand problems and systems iteratively. And in this process, they work like researchers by formulating questions, conducting experiments with the system, and evaluating the results. And we can have them tell them to have conversations with the system in this process because they perform so many small experiments and ask questions to the system. And it is important that we can make this conversation, Nils style, vivid and extensive. And to achieve that, there are different exploratory programming systems which support some kind of liveness and just short feedback cycles to allow for frequent experiments. There are different examples of such exploratory programming systems, such as operating system cells, such as computational notebooks, or different Smalltalk systems, all of which provide different interfaces and tools for different activities, such as including domain-specific and task-specific tools, such as code browsers or debuggers. But all of these tools have in common that we need to ensure that we have that liveness and that feedback cycles, and to enable that, we have the challenge of making sure that programmers can really convey their intentions to the system. And this can be pretty complicated, as can be seen from this model with the two gulfs of human-computer interaction. So on the one hand, we have the high-level goals or the mental model of users, and on the other hand, we have a physical system or the technical implementation. And whenever programmers want to convey their intention to the system, then they have to gap this gulf between these two, which is called the gulf of execution. And also to understand the results of the system, they had to interpret the display, the results displayed on the screen back in the mental model. And so this creates a lot of semantic distances which can hinder effective exploration. And on the other hand, as already mentioned before, we already have different applications of generative AI for programming. Most of you will have used something like GitHub Copilot for code completion, but there are also other tools such as conversational agents for IDEs or code review tools. But all of these tools are very code-centric, so they mainly neglect any available runtime information. And so this leads to our approach. We propose a semantic object interfaces framework where programmers can ask functional and epistemic questions, so they can ask high-level conceptual questions about objects in a system, and they do not have to perform manual experiments, but instead they can ask these questions to an exploratory programming agent, which then automatically plans experiments and evaluates and iterates as necessary. And internally, only this agent then interacts with the system by inspecting the state of object, browsing the implementation of objects, or sending messages to them. The agent also has access to a list of policies that describes its behavior, and also to a conversation history to allow for all the questions being asked in the context of former questions. There are different types of questions. Functional questions are about the state of domain objects, such as in a shop system, for instance, you could ask when an order was created, or epistemic questions are about the behavior of objects in a system, such as how does the ranking in a shopping system work like. Okay, and given that framework, we then can think about how we can actually provide these semantic object interfaces in exploratory programming systems. And for this, we have identified two different interfaces, two different starting points that programmers frequently use when they want to explore objects. The first one of them are object inspection tools, which regularly display something like a list of variables and properties. And to this, we add a new conversation mode, so programmers can also, instead of just viewing the raw state of object, have a high-level conversation with the agent about the object. There's also another frequent starting point used for exploration with the scripting. So we often have something like a REPL or a debugging console where programmers can type in technical commands, or in object-oriented terms speaking, where we can send different messages to domain objects. but this requires an understanding of the precise vocabulary of these objects. And so instead we propose an extension for the scripting language, this for semantic messaging. And so I can just write some kind of pseudocode here, but the important difference is that these semantic messages are not implemented on the domain objects, but instead they are handled by the exploratory programming agent, which will then conduct its own experiments and finally return the answer as another regular code object. Okay, so these are two possibilities for integrating semantic object interfaces. And now I give you a brief overview of how we implemented our programming agent. For this, we used the large language model GPT-4o. And what we basically did was creating a large system prompt where we describe the expected behavior of the agent, including things such as the identity of the agent and the expected output formats. Something interesting is that the LLM by default is very lazy and does not perform a large number of experiments, so we stimulated it to more exploratory practice by including a larger number of experimental samples within the system prompt. Also, we need to provide the LLM with access to the system, for which we provide different functions for evaluating code about the object, or also for browsing different classes, packages, or references of methods in the source code. Okay, so this was a short overview of how our approach works and how we implement it, and now I'm switching over to give you a short demonstration of it in action, and I hope that we will have no further problems with screen sharing, so I hope you can now see a different window. And here I'm in my Squeak image, and I have this order object here from my shopping system. Could anybody just quickly say that they are seeing my demo?
Yes, we can see it.
Perfect. Good. So we have an order object here, which is something from a shopping system. So you might stumble upon this in any context, just as debugging a larger issue. But for now, we just want to know when this order was created. And to show you how complex it is to answer this question with traditional tooling, I will just try it. So we want to know when this was created, so we can take a look at the different variables here. This one is probably not relevant, so I can take a look at this properties object here and find some other state nested in it. And finally, here is some kind of number for the creation date, but I cannot really say what dates it represents, so I need to convert it first. So I can try out some scripts, such as assuming that it's a Unix timestamp, use this conversion code, but it does not make sense. This object was surely not created in the year 56,000, so maybe this is a Unix millisecond timestamp. So I divide it by 1000 and finally gets the correct answer. But you can see that this involves a lot of technical overhead and different tools and interface being used. So I instead can also use a chat mode, which we have integrated here, and ask instead in plain English, when was this order created? And then the agent starts to analyze the situation by itself, finds out everything what we have found out before, tries out different conversion methods, and in the end, it has found the, so we can see all the different steps in the code it evaluates. And I have to say, sometimes it works faster, sometimes it works slower. And in this case, we finally have the correct answer here. Often this works faster, but even in this case, you could see that I just have to type in a single question and wait for a few seconds instead of using all different tools manually. This was just one example. Give me another one where we have a formatted text object, which is used in Squeak for using different attributes for adding emphasis to a string. And now I'd like to understand what this object represents and how I can use it. And for this, I can again go into this chat mode here and ask something like, what attributes do you have? Note that I also can talk to the object in the second person. And then the agent finds out that we have different emphases with the code 1 and the code 4 here. And then I wonder, what is this code? What do these codes mean? And so I ask, what do these codes mean? And the agent starts researching the different documentation artifacts available in the system and comes up with this summary. And finally, I also wonder how we could, for instance, change the attributes of this text. So I could ask another question like, give me different code samples to make this all italic, and then the agent starts to research the available protocols on the text object and comes up with, for instance, this example here where we use the add attribute from to method. Okay, so this was about the demonstration, and And in a sense, you could see that we can use different, can ask different questions to explore the state of behavior of objects here. But we wanted to go further. We did not want to only support object inspection, but also provide semantic interfaces for other programming tools. And for this, we made the observation that many softwares, not even only programming systems, have object-oriented user interfaces. So you literally can see the single domain objects on your screen. And for this, we proposed that we can add a generic UI mechanism that allows programmers to click on one of these domain objects and then have a conversation with them through the exploratory programming agent. So the individual software does not need to provide its own agent, but instead the exploratory programming agent will find everything about the concrete domain and the required interfaces on its own. And then we can see that many exploratory programming tools that we have today already employ object-oriented UIs. For instance, code navigation tools provide access to the different meta objects such as classes and methods, or editors provide access to the different nodes in the AST of a method, or debuggers provide access to the different parts of a process. And so we can use our generic UI mechanism here to talk to the different code artifacts which we can see in the programming system. For this, I have another short demonstration for you. I'm opening a debugger here where you have a typical situation of seeing a complex call stack with a lot of methods and a lot of variable and other information. And I have just a simple question about a single parameter here, and then I would like to know, where does this come from? What is this about? What does this fail block here actually do? And for this, I can switch into this chat interface here and ask, what is fail block from? And where's fail block from, and what exactly does it do? And when I ask this question, then the agent starts to investigate all this call stack and additional information, and comes up with an information about the different methods where this could be from. Or I could also ask what exactly will it do to further stimulate the agents to find out what the block does itself. And finally, we also get this information. It attempts to visually flash the editor and the compilation, if the compilation fails, and this is actually correct. Okay, so this were about the demonstrations, and now I'm moving over to the discussion. We discuss our idea first with respect to the feasibility of our agent, and second with regard to the impact on the exploratory programming experience. Let me start with the feasibility. We see two things here. First, we take a look at the limitations of LLMs which affect our agent. We could see that in some situations the agent would provide errors, so it would hallucinate or would conduct incorrect reasoning. And second, we also see some failures. We have seen in some of the demonstrations insufficient answers where I had to reiterate and ask follow-up questions to get correct answers. In other situations, the agent would just never and to experiment. But in general, we think that these are no systemic limitations, but can be improved by training a large language model for specific abilities, such as working with the Squeak Smalltalk framework in our context, or working with exploratory practices. We also have some performance considerations. For simple tasks, this is usually not a large problem, where we have pretty small delays and financial expenses, but in more complex situations, delays can increase and monetary costs can too. If we, for instance, use the agent for an entire hour, we could spend as much as $60, so surely some further optimizations are required here. But the good news is that we have some ideas to improve the performance situation by fine-tuning a smaller language model or optimizing the prompts. So our current prompt is, if you print it in paper, which I actually did for my thesis, a couple of pages, and I'm confident that this could be shortened to improve the performance. Second, we have the programming experience, and here we can notice that semantic object interfaces provide a higher abstraction level, so we can reduce interruption and cognitive overhead for programmers while improving the semantic immediacy and the flow of programmers. But like many abstractions, also semantic object interfaces can eventually leak when the agent fails. And in this situation, the programmer needs to start all over again and take a look at the manual artifacts that they have tried to avoid and learn about before. And also there's a risk of missed serendipitous discoveries. For instance, when you are manually searching for a method, you might scroll through a lot of source code and learn a lot of other things that you might need later. And such discoveries do not occur when you use an automation for the search instead. Because semantic object interfaces have a natural language interface, we also can reduce the gulf of execution and evaluation by avoiding technical interfaces. And the conversation history allows for asking questions or asking follow-up questions in the context of former questions. Mentions the limitations of language models, which lead to a limited trust in their agents at this moment, which can create larger temporal distances. Sometimes it's just too expensive, and there is also the danger or the problem of using too much energy and water. So, for instance, if they would use our agent for an entire workday, depending on the region, you might spend as much as several hundreds of liters of water. So, this is certainly something which needs further attention. Finally, some ideas for future work. I already mentioned that we need to improve the capability and the performance of our agent. And another issue which I think is even more interesting is researching other ways to improve the collaboration of programmers and exploratory programming agents. So at the moment, we have something which is more or less automation, but it's important that we also keep programmers in the loop. And one way to achieve this could be to improve the explanation of the steps and the answers of the agent, so that the programmer can also continue on the steps of programming agents, even when the answers were not yet perfect. Okay, to quickly conclude, we have proposed semantic object interfaces that allow programmers to ask high-level semantic questions about objects in a system and answer them through an exploratory programming agent. We have provided different ways to integrate them into programming systems through different tools and through semantic object interfaces and through semantic messages. We have presented different applications for different tasks and domains of our approach, and finally found out that semantic object interface improves the semantic experience of programmers, can reduce cognitive overhead, but at the same time can also reduce the opportunity of serendipitous discoveries. Finally, we see that we need to optimize and fine-tune language models for exploratory programming specifically. Thank you a lot for the attention. I hope I have not too much overtime from the technical problems. And after the discussion time is over, I'm still happy to take any questions on Discord.
Thank you, Christoph. So we do have time for questions.
That's great.
You need to speak directly
right into the mic.
It's highly
directional. Hi, thank you for the talk. This was very interesting. I had a couple of questions. First, I think you mentioned during the talk that your agent can execute code. Is that correct?
That's exactly. So I mentioned these three kinds of experiments that the agent can execute. One of them is inspecting state, and sending messages is another one. And sending messages essentially means to generate and execute code on its own. Yes.
I see. Okay, I was going to ask, are there other tools that you make available to the agent? Like, can it grep through the source code, or sort of the other suite of tools that you typically see for software agents, or is it's just the execution?
Well, it's more than execution. So browsing the implementation essentially means that the agent can take a look at the comments and yes, basically at the comments or at the organization of source code. So it's more than just accessing, more than just generating code.
Okay. And then I think the second question is kind of related, which is how do you construct the context that you give to the model, I guess at the very beginning? It sounds like the model can do some exploration on its own, but do you sort of preemptively decide, hey, you probably want to look at the source code of the object, or what do you provide in advance, and how did you decide the breakdown between what you sort of proactively show the model versus what the model can query for?
Yeah, this is a very, very interesting question, and there's a lot of research going on prompt engineering in general. So what we do at first is we have just textual explanation which describes in great detail how you should look at objects by sending messages and so on. But specifically, we something like in the beginning of each conversation, we want some first experiments for the agent. This includes just getting all instance variables of an object and getting a textual representation of the object. And this is some initial context. And something else which we can do is that we, for specific domain objects, such as in the debugger context, we also provide some other information. So in the debugger context, we actually pre-generate an excerpt of the entire call stack. So the agent is just like this. Suppose the agent already sees some relevant information without needing to perform initial experiments on its own. Does that answer your question?
Yeah, that does. Thank you very much.
I have a question. I may have missed it in all the confusion, but what's an example of a serendipitous discovery?
Yes, okay. So the idea here is that when you work with the system on your own, you just see many information. A lot of them are not relevant, or at least not immediately relevant, but at some point in the future, you might remember something you have seen by accident. So one example of this, if you want to find a message that solves task X, you scroll through all methods in a class or in an object, and 90% of them are all irrelevant, but just by seeing them, you already form some kind of mental model of the capabilities that the class offers. And later you might remember some things, and you can use them later for doing any other tasks, or you read some comments that teach you something about the internal implementation. But if you automate this, then you just do not learn anything about this at all. So you just get the final answer. And when you later need another information or in another context, you do not have it or have to ask for it separately.
Okay, so what is the most surprising result that it gave you in your experiments?
A lot of things have happened. One example is that I had a tool for accessing commits from GitHub, and I asked the agent about this tool object. Can you please give me my API key? So the task was that it was just a configuration for the relevant entries. But then it said, sorry, I cannot provide confident information, which does not make sense in this context. But it was very confusing in the beginning.
Okay.
Something else was more like that the agent would never stop, so I asked it to visualize some dictionary, some table of data, and it was almost there, but some numbers were offset, and when I asked it to correct it, instead of correcting that, it came into some loop of correcting itself all over again, and in the end it questioned basics of the language syntax and spent $10 or more before I stopped it after 10 minutes. So it completely lost the track here.
Okay, thank you.